All right. Hello, everybody, and welcome to the SIG-Windows introduction as well as deep dive. I know we don't have a lot of you guys today. We actually have a conflicting Windows talk right next door on Windows storage. So for any of you that also want to watch that one, I'm sure they'll have them recorded so you'll be able to check it offline and vice versa. Those guys will see ours. My name is Michael. I'm a Director of Product Management at VMware, and I'm one of the two chairs for SIG-Windows.
Yeah, I'm Patrick Lang. I'm a developer at Microsoft, focusing on Kubernetes upstream, and then, of course, I hook some of that stuff up in AKS as well. So, yeah, we get started.
All right, so let's get started. We want to keep this interactive. This is one of the SIG-Windows talks, so if you guys have any questions or anything that you guys want to ask, raise your hand. If we address it in a future slide, we'll ask you to wait. Otherwise, we'll answer it right away. All right, so I want to talk to you a little bit about how we got here. So when we started SIG-Windows, initially it was more of a proof of concept. We wanted to make sure that the things that we wanted to accomplish were possible within the Kubernetes ecosystem. And then we started to put the right pieces in place so that it can get us to GA. So our first release was with Kubernetes 1.5. And that release really centered around showing the art of the possible, illustrating to everybody that you can have a kubelet, it can run on Windows, the same thing with the kube proxy, and we can schedule containers on the kubelet and on the node, effectively managing them using Kubernetes. There were a lot of hacks into that release, and we admit that, but it kind of rallied the community behind our effort and allowed us to make more contributions from many companies to get us to the next stage, which was with version 1.9 in December of 2017. That's when we announced beta, and we started gathering a lot of momentum. A new version of the operating system was out. We had advancements at the networking layer that allowed us to start building CNIs on top of our solution, and then we started kind of streamlining all the things that we needed to do to get to GA. With Kubernetes 1.14 in March of this year, we had our stable release that allows you to run production-level workloads on Kubernetes. That means we will support you as a community if you want to put your business applications on Kubernetes. Now, that doesn't mean that we're completely done. There's a lot of work that we have left to do. There's features and capabilities around the ecosystem of Windows containers, in addition to features of Windows itself that we need to work on. With your feedback and the feedback of our community, we'll prioritize some of those, and we'll walk you through some of the future investments in a few minutes. So how did we get here? So Kubernetes 1.14, if you guys are familiar, that's the Kubernetes logo that
Aaron,
Aaron, the SIG beard, decided that was going to be the logo for this release. Patrick, myself, and our entire SIG-Windows team really worked day and night the last couple of months to get us to GA. That means you got Windows Server 2019 support. We've had significant advancements in code quality and scalability of Windows containers in Kubernetes. And then we did a complete end-to-end validation of user scenarios. If you're familiar with Kubernetes, there's a process called the Kubernetes Enhancement Proposal, or the KEPs. So we had to write a very detailed KEP that outlined what you will be able to accomplish, what won't work, and what may never work with 1.14. And we went through that list exhaustively, both as a team and in addition to that in our automation. In addition to that, in 1.14, we had the alpha release of the GMSA. GMSA is an acronym for Group Managed Service Accounts. Think of them as a way to provide an identity in Active Directory for your workloads running in Kubernetes. So now you can assign to your pod or to your container a GMSA that's managed by your AD administrator and assigned to the node where your container is running on. And then any outgoing calls on the network from the container will carry that identity. That's very useful in Windows workloads. Think of the ability to reach a file server that's called for that identity, or reach a database that will only authenticate a specific account. So as you're running distributed applications across your Windows ecosystem, that's a necessary component to make that possible. We will continue advancing that work towards stable, probably towards the end of this year. But initial feedback is really great. People are using it. It's worked very well. And last but not least, extensive automation, extensive documentation. So we've spent a lot of time to capture end-user scenarios, getting started scenarios, introducing a node into Kubernetes scenarios. So if you guys are using those and you have feedback, let us know. We'll update the documentation, which you have been doing already. But we'd love for you guys to kind of test drive Windows containers in that regard.
Yeah.
Yes.
Yeah, so the question was, what about Windows Server 2016 support? So one of the things that changed a lot between 2016 and 2019 was actually the way that the networking stuff was all deployed. And that enabled us to actually be able to do multiple containers per pod. But in order to do that, we had to make some trade-offs and remove some of the code that was needed for 2016. And so it didn't really make sense to maintain both of those. And so we focused on 2019 where we could get the better Kubernetes experience rather than restricting the features further and doing something like a single container per pod on 2016. So.
Plans to back and forth at some point. The Windows enterprise, it's really hard to convince guys to invest in the latest servers. They are like, but we have 2008 servers.
Yeah. Yeah.
So,
the Windows team doesn't backport new features like that back to previous releases, and so I don't really see 2016 being feasible. That was, one of our goals in the development process was to get it landed with the next long-term release, which was the 2019, and so that's just what the trade-off that we ended up with there. But that is a release that's going to be supported for many Kubernetes releases, and Microsoft is going to support that for the typical long-term cycle of, I think it was a 5+5 or something like that. So.
And our goal is moving forward, obviously, to support new point releases of 2019, but we had to start with that one. There are a lot of features that we kind of needed that made it important for us to start with that release.
I'm not aware of any SKU restriction. In fact, we might even be able to get Windows 10 working for non-production stuff. But the container role is there in both the standard and the enterprise and the data center SKUs. And so that's what you need to enable on the Windows side as a prerequisite. Then you go and install the components that run on the node, like the Docker Enterprise Edition Basic, the kubelet, kube proxy, and things like that.
I think the only limitation is on the licensing side, how many containers you can run. If you're running data center, you have unlimited containers.
Well, that's only applies to the Hyper-V stuff. So when you're using process isolation, which is what we're doing in Kubernetes today, there's no limitation on the number of containers. So, okay. So one of the big changes that I mentioned a bit earlier was that we changed the networking model in 2019, and then over the course of Kubernetes 13 and 14, we were able to spend a lot of time basically doing some end-to-end testing and tuning the different container networking infrastructure CNI plugins over the course of that. And so Windows itself has kind of 3 different ways that it can route traffic, and that enables different types of network plugins to be built. So if you want to do an overlay network where everything's virtualized and encapsulated with VXLAN, that's something that was enabled as part of the cumulative updates a couple months ago. There were a few things that weren't quite right when Windows Server 2019 released that needed to be fixed before VXLAN would work. But now that's done. And so you don't need to install that KB specifically, you just need to install anyone that's that one or newer. And so as long as you're patching the server, you're going to have what you need to be able to enable VXLAN. And then for each of these networking modes, Microsoft has provided an open source, kind of like a reference implementation. And this is designed to make it a lot easier for you to actually hook your networking up. So we've got a plugin called WinOverlay that works with with overlay networking. But basically what these do is program the network interfaces. So where people may have gone and created a virtual network adapter and then applied IP tables on Linux, instead you can call this pre-made CNI plugin. It calls the right Windows APIs to configure those adapters the way you want, and then you can go from there. And so things like Flannel that can actually build on top of this. So what happens is Flannel can call out, get the IP address, DNS server, all that information that comes down the channel through CNI, and then it will basically delegate out to this WinOverlay plugin to actually do the adapters. So if you want to do like a custom IPAM implementation, which is like the case of what was done for Google Cloud Engine to bring those tests online, Peter Horniak and Yuju Hong basically built on top of the next one, which is the WinBridge plugin. And but they basically just use that delegate as is. And so we expect that to make it easier for other plugins to be developed on top of that. So the next two networking modes are very similar, but there's one key difference between them. So an L2 bridge is going to give a network interface to that pod, and then it's going to get a regular pod IP, and then we program all the routing rules through kubeproxy there. And that's basically the same way that like KubeNet works, or if you're using Flannel in the less common host gateway mode, that's the way that's going to work as well. So whenever services are started and then shut down, all these rules need to be reprogrammed by kubeproxy plus that, but it works pretty well. However, once you're at a larger scale, then that's where the VXLAN can work a little bit better, because some of that data plane stuff you don't need to redo all the routing rules just because a pod was added or removed. And so it becomes a little bit simpler. And
actually, on top of that, because of all the redoing of the routing rules, we've had some performance issues in the past that we've addressed. So we got feedback from the community. The team at Microsoft and the Flannel larger team did go and work on that, and now it's a lot more efficient in terms of how it's configuring that. Yeah.
And then the similar mode to L2 bridge is one called L2 tunnel. And so if you've got, like a top of rack switch or some sort of network appliance running, you could actually program that to route all traffic for you. So instead of having to handle all the routing rules on the node, you could basically delegate that to something else. And so 100% of your packets will be forwarded to that and then distributed from there. But if you were going to do a different type of implementation, like I've seen this done in Azure as well, for some of their appliances, they will use the tunnel mode rather than the bridge mode. So that way they're not making those routing decisions on the node, it's being done after it leaves the box. And then the last one is for the last, since probably 2012, I think, maybe earlier, Microsoft has had what's called a virtual switch extension that actually started in Hyper-V. But what it lets you do is just completely replace the network stack. And so the Open Virtual Switch from the OpenStack project can actually be used instead. So if you want networking infrastructure that is consistent and managed using Open Virtual Networking, using like an OVN controller from OpenStack, you can actually use that as well to give all of your pods connections using that Open Virtual Switch and Open Virtual Networking combination. And I think that's sort of similar. Like, doesn't NSX do something similar to that?
Yeah. So NSXT, the CNI for NSXT is using Open vSwitch as well. The one good thing about OVN Kubernetes is that it's the only CNI from the open source that we have that does support network policies. So if that's something that's important to you guys on the open source side that supports it.
Yeah.
If you're looking for the most stable CNI, probably what we've heard so far is the Flannel host gateway is the one that most folks use, but it's more of a basic network implementation. So as you're advancing and you're putting a little bit more security and hardening your environment, then CNIs like the NSXT and Calico and others that are coming down the line are going to kind of fill that gap.
Yeah. And Calico actually, or rather Tigera announced that they're commercially supporting Calico on Windows just for the policies right now. They're probably going to do more later, but that is something that's available both in the open source project and commercially. And so we expect more and more stuff to come in this ecosystem as people are deploying more things in enterprises. Yeah. So the question is, do we plan to support SRIOV? So the answer on that one is that probably not immediately. In order to do that, we would really need to get the Hyper-V isolation layer in place first, because that's needed to be able to create and manage the virtual functions. So the Hyper-V support in Kubernetes is still pretty early, but once we get that developed a little bit further along, that would be a good time for us to look at that. But yeah, that's a good piece of feedback, because it works for VMs today, and so we should be able to make it work for pods once we get a few other prerequisites met. And I've actually got a slide later talking about how we're changing some of the runtime. I don't talk to SRIOV specifically, but there's a few things we need to do to get more of the features of Windows working. Yeah, another question?
Yeah, can I just say something about Tigera's stuff?
Oh, okay.
We actually do have... on the commercial side, Tigera does have a CNI plugin with BGP support and VXLAN. So we just released the VXLAN one a few weeks ago.
Oh, okay.
And yeah, we have that commercially supported policy engine as well.
Okay, good. Glad to see the ecosystem building solutions. Okay. So when you're going to start deploying things in a mixed cluster, there's a couple of things that you need to look at. So if you only wanted to run Windows apps, then what you could do is basically just run your control plane on Linux and then add a bunch of Windows nodes. And you could do that, but if you want to start using some things like, ingress controllers and stuff like that, most of those are still running on Linux today, and so you'd have to run them on the control plane. What I expect is that actually most people will probably start with an existing Linux cluster that's running some Linux workloads and add Windows nodes to it. And if that's not what you want to do, let's talk about that in more detail at the end. But in that mode, the easiest way to avoid breaking stuff is to go ahead and add a taint to the Windows nodes. And then when you create a deployment, you just put a corresponding toleration on there. And so that'll make sure that, if a developer just, launches a Linux workload and they haven't put a node selector on there saying that this is Linux only, then it will still land on a Linux node.
And the current expectation on that is that most customers have a tremendous number of investments into existing YAML files and pod specs for their existing apps. We didn't want to impact the Linux ecosystem where they had to go and change every one of them and put node selectors in it. So the easiest way for us was to, as Windows was just going into GA right now, allow you guys to go create the taints, add the tolerations, and since you're writing new pod specs for Windows workloads, and it's a simple addition to add, and it enables you to kind of isolate your Linux workloads from your Windows workloads. Yeah. In fact, some of the distributions that we have that are the turnkey solutions automatically add the taint for you.
Yeah. And the other thing related to that is in Kubernetes 1.15, there's a proposal to add scheduling constraints to what are known as runtime classes. And so runtime class is a new field that was added as alpha in either 13 or 14. But what it lets you do is define basically a, I'm actually going to step back a bit. So one of the first use cases that they had intended for runtime class was if you want, when you're doing a deployment, if you want to have a group of settings like I want to use Kata and I want these other settings applied on the Linux side, and I've got other deployments that I just want to run using Docker without Kata, then what you could do is create two different runtime classes. This gives admins a way to sort of codify what settings they want to pin on all the deployments, and then the admin or developer that's deploying their app just says, give me runtime class, isolated, or give me a runtime class, whatever. One of the things that's proposed in 15 is having a runtime class automatically add constraints for you. And so then what we could do in a deployment is just say runtime class is Windows 2019. And so that would give you a really easy one-line view that would automatically do the right thing on the scheduling side. And so that's something that I'm still waiting on the code to go in, but once it's there, that's something that we could definitely use some help validating to see, like, does this make sense or not? Because I'd like to be able to do things like say, here's a runtime class for Windows process isolated. Here's a runtime class for Windows with Hyper-V isolation. And then you could even go a little more granular than that if you want to do things like segment workloads into different groups with different settings with things like CPU limits and stuff like that. Because there's a lot more stuff you could do under the hood with Hyper-V involved. So the other thing you need to look at when you're doing a pod spec is that some of the Linux templates have like really low memory limits of like 100 megs or so in some of the examples. And if you want to start a Windows pod, the container is going to need at least 300 megs. And that's because all the Windows services like the local security agent and things that are needed to support a lot of the identity APIs and stuff within that container need to be duplicated for each container. They're not shared, they're always isolated. And so like this concept on Linux where there's like a security option that says run as non-root isn't there because on Windows that identity is never shared between the host and the container. It's coming from a completely separate security database.
And actually, the other thing on that as well, we've heard some feedback a few times so far that it takes some time to start Windows pods. If it's the first time that you're downloading the image from Docker Hub or whatever else you're downloading it from, they're not 50 megabyte images. They're a little bit larger. And even though Microsoft has made a lot of advancements in reducing the footprint for Nano Server or Windows Server Core, they're still several hundred megabytes. So factor that in if you need to distribute your pods or if you want to preheat them, make sure they're already on every node that you will need. And once the base image is there, then all the operations are going to be very fast, both in terms of scaling or first startup of your containers.
And the other thing you need to be sure to check on the deployments, like we already had the question about the Windows version support, and that is that you need to make sure that the container version matches. So if you try to deploy a container that was built using Windows Server 2016 on 2019, today it's going to fail. And likewise, they just released a Windows, I think it's 1903, which is weird because it's not 1903, it's later than that. But that release that just came out is going to have corresponding container images as well. Those don't work on 2019. And so the best practice is that whenever you're going to deploy something, when you're building it in your Docker file, make sure that your from line is using a container with a specific OS version in the tag. And so if you go and look at things like the Microsoft ASP.NET images, you'll see things like 4.7.2 Windows Server Core 2019, something like that. But that way you could tell what the OS version is. If you use latest, some of those ones are designed to be able to let you match the version that of the machine you're building on. And so if you're using Docker for Windows on a laptop running 1903, if you use latest, you're going to build a container that's based on 1903, and then it's not going to work on 2019.
Yeah, and a couple more things. 1903 is not supported in Kubernetes just yet. So that might be something we'll address in a future release, but with 1.14 it's not supported. And earlier we talked about taints. So a very good practice is not only tainted saying in Windows, but you can actually indicate the version of Windows. So for example, you can taint on Windows Server 2019 or 1809. It's the same OS. And that way, when you're building your pod specs, you can add the toleration for the exact same version. That's a good way to make sure that if you have multiple releases of Windows, maybe with 1.15, 1.16, then all your images are landing on the exact same OS as well. I believe you had a question?
Kind of partially answered, but I was wondering if there's going to be like any improvement on that, like precise version matching. Is that something that you're working on?
So the last line here.
Yeah, and so the patch version can differ. It's the major version that cannot. And so you can't run 2016 on 2019, you can't run 1903 on 2019. But if one of the images was built against the December patch level and another one was built, and then your machine is running the latest patches for May, the demo I've got set up is actually doing that, and that's fine.
Does that always work? Because I thought it was blocking me when I tried
it didn't work in 2016. It works in 2019. And so they're basically trying to make sure that those patches don't introduce differences there. The other thing we're doing is with the Hyper-V support, it's going to be possible for a newer OS like 1903 to be able to run an older one. But right now that's still not quite working 100% in Kubernetes, and that's one of the areas that I'm going to be working on over the next couple releases to get that better. But that would allow you to keep updating the servers without having to rebuild the containers. So, and so, you know, if anyone, let's just show hands. What was the biggest feature in 1.14 that we did for Windows? Does anybody know what this is over here on the right? Well, Craig does, but so that's test grid. So every single Kubernetes release has a number of dashboards owned by each SIG, and that shows all the testing that they need in order to verify that things actually work. And so one of the really big struggles that we had was going through hundreds and hundreds of test cases, getting them adjusted so that they would work across Windows and Linux, adding new ones for Windows, and that was like, you know, the biggest effort we had over like versions 12, 13, and 14. And then when we shipped 14, we finally got all of that green. And so when a Kubernetes release is cut, they fork the test and they keep that running. And so, you know, if I were to summarize, what does it take to GA something in Kubernetes? It means getting test grid green. That is the biggest factor, because that's the only way that you can prevent other people from breaking you. And so, you know, we finally got to that point for 14 and GA'd, and then now, you know, there were no bugs introduced in 14.1, 14.2. Those all work great out from a Windows standpoint. I don't even know what the fixes went in them.
Yeah, it's a big shout out to the community. A lot of folks from Cloudbase and Patrick, you know, they spent a tremendous amount of time getting this to green. That involved evaluating the entire suite of tests that Kubernetes had, identifying some of them that are not applicable to Windows because of features that we don't support, and then reducing that list to the things that we really do support, adding new tests to test our new functionality, and making sure that that test grid becomes green and stays green throughout the release. Yeah. So that was a lot of work.
Yeah. And so if you go and check that out, if you want to know the quality of combinations like how's it running with Azure CNI, how's it running with Flannel, I'm in host gateway mode, how's it running with Flannel and overlay mode. All those tests are public on there. And so we've got, I think we're up to something like 8 or 10 test passes there. And then since that point, what we've also been doing is working closely with the conformance working group and SIG testing in order to keep making the testing better and take some of those things that we forked and bring them back into one suite. And so I'll be going to the conformance working group meeting later today, but I think that within a couple of releases, we'll get to a point where the Kubernetes conformance logo could also be applied to Windows. We're just working out some of the details of how that testing is actually going to happen. But that's one of the things that's been really fun about working in this community is that by working together, we're building stuff that's better in the end. And so like a lot of the things that we did to help make Windows and Linux work well together are also helping pave the way, and we're also joining forces with the people that are doing things like getting stuff running on ARM64, handling multi-architecture images, and stuff like that that's needed to test all these new scenarios that people want to do. And so it's been a really fun community effort from that side.
Yeah, and absolutely. And on the conformance testing, there's a open source tool called Sonobui that kind of validates conformance across a cluster. So if someone wants to have their own private distribution, Sonobui is what they use to kind of validate that. So we're working on going down the path where Sonobui can validate Windows clusters with our conformance profile and the work that Patrick mentioned earlier.
All right.
Why does that stuff run?
Huh?
Why does TestGrid all run? Is it
Well, so
something restricted, or is it different people running it?
Well, so the best answer, so the question was, where does TestGrid run? The best answer would be, look at the talk that Aaron Krickenberger did at KubeCon US in December, because they had a whole talk about the Kubernetes test infrastructure. But there's kind of two main components that are open source, and they're used, actually no, TestGrid is not open source, but the format it reads from is. And so like Prow is what handles merging all the PRs and scheduling all the test passes. That's completely open. And then for each one of these test passes that we have running, like the 1.14, like the one on master branch, like all the different iterations there, those are all scheduled by Prow. And then the results get uploaded to a Google storage bucket, and then TestGrid parses them from there.
But the actual tests, like at least for Windows, we're running them all over the place. So we have a vSphere suite that's running on vSphere on-prem. We have test suites that are running on AKS. So we have multiple locations where we're actually running the tests, and we're getting results across the board of. We also have a GCP test suite as well. So the actual compute environment is different, but they all get pulled together and they're displayed in TestGrid.
Yeah. And so if you wanted to add a test pass, for example, a new CNI, you can go basically take a copy of the job definition that Prow does, and you could set that up and run it. The other thing you can do is like what's going on with vSphere is you can also just run the same test suite and then upload the results to a storage bucket, and TestGrid will federate them out for you. And so that might be the easiest way to do it if you've already got your own test lab. My test lab has, 50 data centers, so, but. All right.
All right, so let me ask you guys, how many of you guys have scheduled the Windows container so far? A few of you. How many of you have done it on Windows Server 2019 with Kubernetes 1.14?
You have.
Oh, thank you, Craig. I love that you raised your hand. So that's great. So, if you guys have tried that whole process, there's some difficulties, right? You have to follow our docs line by line, don't make a mistake. You have to make sure you set up, if you're using Flannel, set up the right, start up the Flannel the agent, make sure you configure everything properly, give it the IP addresses and the ranges. So all of that stuff is a little bit complicated. So we're going to do a lot of things to make that easier for you. We're going to talk about kubeadm later on, as a premier provisioning and node addition tool in Kubernetes and how we are working on that. But we're also working with a lot of vendors that are providing turnkey solutions that it's simply like select what you want. I want a Windows cluster, I want this many nodes, I want this type of compute profile on it, and you wait a few minutes and you have a cluster up and running and ready for you to deploy your application. So the entire end-to-end process is significantly simplified, and they offer a lot of other things like services and support, and you get a throat that you can choke if you get an issue. And most of these vendors, Patrick and I do come from one of each of these vendors. They also do work in our community. Some of them have developers that are working with us, and that's how they stay engaged. They kind of make requests for their features, and we put them to work as well. So we have a very good two-way communication with all of them. We put them in alphabetical order here so nobody gets upset. So we're starting with Amazon AKS, Docker Enterprise, Google GKE, Huawei Cloud, Microsoft AKS, Rancher, Red Hat OpenShift, and VMware Enterprise PKS, VMware Pivotal Enterprise PKS. So if you guys are interested in trying them out, when you do get the deck, there's links to the sign-up pages for every one of them. Some of these are private betas, so we can't guarantee that you will get in and you'll get access, but at least you can do is try. So if you're interested in any of these, follow the links and go sign up. Yeah. So before we get into the future plans, I did want to give a shout out to some of the companies that really did put a lot of development and R&D engineering behind SIG-Windows. We had Microsoft, Docker, VMware, Pivotal, Google, and cloud-based solutions. Each and every one of those companies added developers, resources, they ran tests, they basically helped us fix bugs, write documentation, and a big shout out to all of those guys that helped us get to this point. Apprenda as well. Apprenda is defunct now, but yeah, we'll give them the shout out. All right, so let's talk a little about the future.
Okay, so one of the things that I'm working on right now is actually getting support for CRY Containerd on Windows. So for those of you that don't know, this is so this container runtime interface is CRI, and it was basically designed to make it easy for the runtimes to be pluggable underneath. When Kubernetes started off, had a code base called Docker Shim, and it was calling the Docker API underneath. Today, there's two other implementations. One is well, there's more than two, but the two that a lot of people are migrating to are Containerd, and which is an open source project, and then Cryo, which was started by Red Hat, but they're both public open projects. And part of the reason for this is that the Docker API doesn't know what a pod is. And so there were a lot of workarounds that had to be done to kind of cobble things together with, where the kubelet would, do things like set up C groups on Linux, copy some namespaces in when they were starting containers. And there were a lot of things that were just kind of hacky to make it all work. And CRI cleans a lot of that up. The other thing is it gives us a place to abstract away the OS, some of the OS specifics underneath. And so that way the implementations can differ a bit more. And so it means that those are pluggable. So you end up with, on Linux, you've also got, like the Kata runtime can be implemented through CRI under Containerd, if you want KVM-based isolation. On Windows, we do process or Hyper-V-based isolation. But the important thing about Containerd and Windows is that the team that's actually been developing all of the back-end kernel code to make containers work on Windows is also the team that's been working on the Containerd project. And so as new Windows versions are being released and they make improvements to the container runtime, to unlock those capabilities, I need to be using Containerd as well. So that way, we've got the container runtime sort of up to date in lockstep with the Windows development as it's happening. And this is pretty consistent with what a lot of the other vendors are using for the runtime. And then Docker itself can run on top of containerd as well. So it's got a nice common shared layer underneath there. But when you've got a node where you're not going to be doing builds and stuff like that, and all you want is a secure container runtime, then Cry Containerd fits that bill very well. And so that's what we're currently working on. But in order to get that done, we've got a lot of hurdles that we need to overcome. Containerd doesn't have Windows builds published yet. The code to make Cry, the CRI interface work on Windows is still not merged yet. And so like right now I'm building these, as we're getting up to an alpha quality, but the goal is that when this is ready within the next release or two, and we want to graduate to beta, it should be something where you could just build a node, install this instead, and have the same capabilities you would have had if you were using Docker. And so that's kind of like what the bar that we've set for beta. And then once we get to there, we could start actually doing some of the new development on the Windows side. And that's where I'm going to resume development on Hyper-V. Because Containerd gives fine-grained control over the stuff that's needed in Hyper-V. And so when we want to do things like start building backwards version compatibility, if we want to do things like put stronger resource controls on memory or CPU, I don't know if you've heard of any of these CPU vulnerabilities that are happening, where two things that can get scheduled on the same core might be able to leak some data. If you use a hypervisor, you can actually restrict it down and set different boundaries, so that way it would be feasible to create a pod where it's like it owns these cores, nothing else can touch them. And so when you want to do defense in depth, we'll be able to start designing new security profiles around that and implementing them through like a runtime class. So that's kind of the direction we're going at, like at the base layer there. And so we've got this outlined in a KEP. We're working on it right now, but there's a lot of moving pieces to get this done. But what's next on there?
All right, so in terms of 1.15, so like Patrick mentioned, CRI Containerd is going to be over a multi-release, it's on a multi-release plan, but there's also a few things that we're trying to target for 1.15 to make your experience better, and also allow us to better integrate with partners and kind of bring more things into our ecosystem. So CRI Containerd, by the way, is done with collaboration with SIG Node and other members of the community, and Patrick and his team are really working with all of them to make that a reality. So kubeadm, I mentioned that earlier, so we're going to try to get initial support with 1.15 that will allow you to add a Windows node and add it into your environment. And we're encountering a lot of difficulties there. There's a lot of assumptions that are being made, not only in kubeadm but throughout Kubernetes, that there are components that are built and run and execute on Linux, and there are difficulties there in terms of identifying them and resolving them so we can get kubeadm to add a Windows node. And I believe, Lubomir, you added a Windows node the other day, right? Was that successful, or? It works. So Lubomir and a few other folks are really kind of driving that effort from us. Lubomir is from SIG Cluster Lifecycle, so we got to a point now that it works in terms of adding a node. We'll polish that. We'll get an initial release out in 1.15, and we'll greatly simplify your ability to add Windows nodes into an environment. We'll continue making more advancements into this workload identity. So I spoke about group managed service accounts earlier. We'll continue advancing that. We did make some API changes in that arena, and we're making fixes and stability fixes. But we're also going to add support for run as username. So that basically gives you the ability to add an identity to your container. Of course, you'll expect more CNIs and storage plugins. So we are working both in the open source world as well as with private vendors that are having a CNI solution in Kubernetes, so they can port those to Windows. And the greater effort there is, if you are going to make an investment and you want a heterogeneous cluster of Windows and Linux nodes, the CNI that you chose for your Linux nodes needs to also work for Windows, so you're required to have a single networking plane. And on the storage plugins area, one of the things we kind of were working on is there are no privileged containers in Windows, at least not yet and not in the immediate future. And part of that effort means that CSIs won't really all work on Windows within the current architecture. So we're working within the community, and that's the talk that's happening next door to figure out what should we do about storage, what are our options, and how are we going to tackle that. So if you're interested in that, do view the Windows storage talk that's happening now. Yeah. And obviously, we'll be fixing more bugs, adding more scale, and capturing feedback from our community and addressing that one by one. So if any of you guys are interested in coming in and contributing with us, just like the greater Kubernetes community, there's kind of 3 stages that you can contribute. You can start as an end user. That means go read our docs, try out the code, give us feedback, maybe attend community meetings and hear out what we're doing, and that's kind of the first layer of getting started in Kubernetes. By the way, this applies to all SIGs, not just Windows. Then become a contributor. Go find maybe a bug in documentation or a bug in the code and get it fixed, submit a PR, get feedback from the community. We're a very accepting community. We kind of help new folks to get started with feedback. We'll even offer some pair program if anybody wants that. But then once you kind of fix your first bug, we'll recognize you and then slowly fix the second and the third and the fourth bug or pick up a new feature, then you really become a contributor to our community. And then from then on, the next stage is to kind of become a tech lead. Maybe identify an area or new work and kind of take ownership of that. And we've had quite a few folks step up in the recent last couple of releases and own an entire area by themselves and kind of drive that to resolution. Actually, in fact, one of the PRs I submitted the other day was removing myself from the API reviewer in the Kubernetes community for Windows. I really don't have time for that anymore, and I've nominated a couple of other folks that have stepped up and they're willing to be the shepherds of all the API reviews on the Windows ecosystem, along with Patrick, of course. So if you're interested, come and talk to us, get involved. We'd love to have you.
Yeah. And as far as the meetings go, if you join the SIG-Windows mailing list group, then the agenda is open. So if there's a topic you want to present on, if there's just even questions that you want to preload so that we're getting ready to answer, feel free to add stuff to the agenda because we'd love to hear from you. And success stories, questions, failures, I mean, all that's good. It's we don't want it to be just us talking.
Yep. So. Absolutely. All right. So we do have weekly meetings like clockwork at 12:30 Eastern. We realize that that's not very friendly to Asia Pacific or European time zones. Our European folks seem to be managing okay, but obviously if we start expanding our community and it seems that there's a need for additional time zones, Patrick and I are open to that and we can add a second meeting. We do record every single meeting. I think we're one of the most consistent SIGs. We post everything on our YouTube playlist, so you'll find meetings going back like 18 months. And we do have a project board that's linked here that kind of has swim lanes for every single release and what we're planning to do. So if you want to see what's going to come next in Windows, you can read our KEPs, come and look at our project board, and you see what we're fixing, both bugs as well as features. And obviously, help us write additional documentation and user stories if that's your forte. Now, how can you find us? Patrick mentioned the mailing list. So if you want to email us, we're up there. We're on Slack under SIG-Windows channel. My alias is M2, Patrick's is Patrick Lang. So if you want to privately message us, you can do that as well. We have our YouTube playlist on the right. So if you're interested in kind of viewing all our videos, it's right there. Underneath that, we have our entire documentation. So if you go to that URL, you find all the docs on Windows, from getting started to adding new nodes to configuring. That's our Zoom link. So all our meetings are following that. Obviously, if you sign up, you'll see the invite, so you don't really need to memorize that. And then we're on GitHub. You'll under that link, we have our Getting Started guide that has additional things like, hey, I want to become a contributor. How do I get started? We have a contributing guide, both in Kubernetes and a specific one for Windows. It shows you everything from how do I open my first PR, where do I find things to work on, what should I think about if I'm changing an API, how do I collect logs to troubleshoot. So it has a very comprehensive list of things to do if you're ready to get started. All right, so we want to open the floor if there's any questions, and Patrick is going to set up and give you guys a demo as well, since we have a little bit of time. But let's open it up if anybody has any questions.
Get the mic.
No questions? Okay.
Did we cover all of them already? Cover all as we went.
What's the preferred pathway to get support for people looking to implement or, try this out?
Well, the support, I guess, like in all of the open source communities, is on a best effort basis. So if they're looking to kind of become a user, the best way is probably come to our GitHub and file an issue if they've identified something. Or if that's something a little bit more major where they want to have more of an architectural discussion, they can ping me or Patrick privately or come to a community meeting. And we've done that in the past where folks came in and we had those discussions with them. Yeah. But so far, I think everyone that had these queries left happy. And obviously, there's features that have been asked that it's very hard for us to implement because of either OS limitations or Kubernetes or Windows limitations. But we do have an ongoing discussion with those folks trying to help them address it.
Yeah, and probably the Slack channel is probably the most responsive because we've got a lot of people that are involved in there, and particularly for recent issues, it's probably already been discussed there. Like we had one going back and forth with relating to a network problem where just yesterday we're like, okay, here's a patch that's there, and so the people who have been testing it have been confirming on that thread. So that's pretty much the easiest.
Actually, the other thing is within the spirit of the Kubernetes community and how great it is to work on Kubernetes. Initially, when we started, we've had a couple of public cloud provider vendors that had a solution working with Windows. And when others came in and they were asking questions, we've seen one cloud provider help the other, which was amazing to see. The problems and the automation that they need to make is very similar. And they were helping each other, even though they have competing solutions. And that was great to see.
The other channel I wanted to point out is that on the Kubernetes.io website, there's a discussion forum in which there's also an area specifically for Windows questions and answers. So there's a nice community building up on the discuss.kubernetes.io.
I'm sorry, Craig, I forgot to add that to the deck. That's, we do need that. And that's actually one of the pinned conversations there is, what scenarios do you want to use Windows for? So any of you are thinking, hey, do I need this Windows stuff or not? Go read the discussion forum. You see what other folks are using this for. I believe you mentioned that you have Windows Server 2008, right? It's going end of support at the beginning of next year. So there's going to be a tremendous amount of workloads that need to be modernized or containerized. That's a key critical scenario for us that we've had a lot of customers that are wanting that.
So with regard to that and the Hyper-V isolation, is it going to be the only way to deal with those workloads? Or are you planning to open that up a little bit?
So the question was trying to run mixed operating system workloads. So we're not going to see support for anything older than 2016 for sure. And that's because the Windows OS itself had to be changed inside the container in order for the applications to just function. And so there's nobody at Microsoft that's working on container support for anything older than 2016. 2016 is in kind of an odd place because it doesn't have what we need to work well with Kubernetes, but 2019 and newer will. And so that's where we're going to be focusing on using Hyper-V to enable it to be easier going forward. But I don't think we're going to be able to address legacy things like 2008.
So the general practice there is not to grab the Windows Server 2008 OS and run it in Hyper-V, and because the OS is still unsupported, right? So,
yeah.
So that's the general problem. But what we are recommending and seeing is a lot of customers are either taking a lift and shift approach where they're taking that workload, maybe it's IIS-based or ASP.NET or WCF-based, and they're shifting it and putting it inside a container, setting up the same policies and configuration that's needed, maybe setting up a group managed service account so that the workload has an identity in the network, and that's how they're containerizing it. So it's a lift and shift approach, or modernization if someone wants to re-architect it a little bit. But at the very least, that approach works very well because you have the same change it. .NET is backwards compatible. In a lot of cases, that lift and shift is not a tremendous amount of work. In some cases, you might be able to do it within a couple of hours. But it all depends on the application.
Yeah. It's like the application I have here was based on ASP.NET. And let me just find the Docker file real quick. And so this one was actually built using, so this was an application that was running on .NET 4.7.2, and then Microsoft has a pre-built image for ASP.NET, and then this is actually what I mean by the durable version tag. So since I built from this, I'm guaranteed that container is going to be built to run on Windows Server 2019. And so those are all, like if you go and look at the tags on Docker Hub, they'll be described there. And since that already had all the right roles installed, all I had to do was set the working directory to the web service root and configure the app pool and then copy the binaries in there. And so this build can still be done under Visual Studio. I'm not going to go through the whole build process right now, but you can basically build and then use tools in there to actually help you containerize that application. And so like if you're using ASP.NET, then you can just move to a new version of Visual Studio, and it's got tools built in to help you do that. And that's how I initially did that. So once you've got the container built, you can use either just raw pod specs and deployments using the Kubernetes API. And so that would look like this. But basically, I've got the container image. That one happens to be a Windows image. But the couple of things I wanted to call out from the slides were making sure that you've got the node selector, and then you've got the resource requests and limits set high enough for the application to actually run. And so this is up on my GitHub repo, and let me see if I've got that. And I actually presented like an hour-long version of this where we went step by step so that you could try it out. That was recorded at KubeCon back in December in Seattle, but all the resources from that are all available at this repo here. So if you're looking for one place to get the sample apps as well as the step-by-steps for that, check this one out. And with down here, this is the lift and shift. The application they have deployed is the one that was from this lift and shift tutorial. You can also, since it's still using just regular Kubernetes APIs, then you can go ahead and use deployment tools like Helm and Draft. There's probably others that work as well, but those are the ones I use the most to to actually, build a stronger template around the application that you want to deploy. So this one, when I deployed it, I've got the chart set up where I can do two different things. I can either use the developer edition of SQL, which is great if I wanted to, do this as like deploying something for a test pass. I could just use the free developer edition. But I also have it set up where if you want to do production, I've actually got a template in here that works with Service Catalog, where it can go and provision a SQL Server instance using Azure SQL. And then if you've got Service Catalog implementation from another cloud provider, it would work there as well. But that would be how you would, one way that you could do things in a production supported way rather than using the developer edition. So that sort of, drives how some of these things are going to be deployed. And then it makes sure that, the things I specified, like the image name and the image pull secrets from that values file, just get passed into these templates. And so it makes it really, really easy for you to do repeatable deployments. And so once you've actually deployed this, I've already got one deployed here. And Helm gives you, one nice place for that application deployment where you can see all the resources that were created as a result. I thought that said 28 days, not 28 hours. Yeah, so I deployed this yesterday, but we've got the SQL instance and the web service running there. And then let me get the external IP. And then we've already got the service up and running. And so I didn't change any of the code that's there. All I did was do a little bit of tooling to package that up as a container. And then I was using standard Kubernetes tools, like Helm and kube control to actually check that stuff out. And if I want to go actually look at what's inside here, you can use the regular commands like kube control. So I want to do an exec into this one. And I'm going to run PowerShell. What did I do wrong here? Oh, wrong pod. I was trying to run PowerShell in the SQL Server Linux instance, not my web service. Okay, and so this is running inside the container. So if I want to go, look at things like the config that's in there, or I'm not sure what's in there, you can do that. But also, if I want to go, look at the logs, you can do all that stuff interactively. It's just the same way that you do, kube control exec into a Linux container. You could do it into a Windows container and run your shell of choice. And then, so there's the web request. Ooh, someone else just hit that site, good. So all the common tools work. And in the case of kube control, Helm, most of those have Windows builds as well. Right now I'm actually running this on a remote Linux node because that's my easiest way to deal with conference Wi-Fi. That way if I'm in the middle of doing something and it dies, well, tmux keeps it alive and I just reconnect. But so that's got just a little bit of the workflow that's available there. Did anybody have any specific questions around capabilities, or were there other things you want to see, or suggestions for future talks?
All right, we might end a little bit early then today. Well, thank you all for attending. Patrick and I will probably stay here a few more minutes, so if anybody wants to talk to us in private, please do so. Yep. But yeah, check out the slides, the ways to get involved. We'd love to hear your feedback. We'd love to you guys to try this out. And we're going to continue investing in this area. we'll make this better and better with every release of Kubernetes. Thank you all.